igniting curiosity across depots, command centers, and beyond. Welcome to your weekly Depot AI Brief, where emerging AI meets mission-ready insights. This is episode 22. AI Logistics Goes Operational. Today we're breaking down exactly how these AI updates impact our 4 core roles, from the shop floor to the executive suite, and we'll wrap up with key highlights and insights on the commercial tools flashing on our industry radar.
Yeah, it's going to be a packed deep dive today for sure.
It really is. And, before we jump in, I want to set the tone for you listening. We are keeping this strictly Depot smart, so we're skipping all that dense tech jargon. Like, if we mention LLMs, large language models, we're just talking about the core intelligence engine that powers these AI assistants, right?
Right.
The software that basically understands and generates human language.
Right, exactly. We want to keep this grounded in reality.
Yeah, so imagine the network goes completely dark at CCAD, Corpus Christi Army Depot. Maybe it's a coordinated cyber attack. The supply chain is totally stressed, network alarms are ringing everywhere, and this is the key, the mechanics on the floor, they don't miss a single beat.
Because they're completely self-sufficient.
Exactly. They keep turning wrenches because the intelligence engine they need, to diagnose a really complex Black Hawk engine failure, it's living right there on their disconnected, ruggedized tablet.
Which sounds like science fiction, I know, but we are definitely crossing a threshold this week. I mean, the conversation across the Department of Defense is really shifting. It's moving away from what AI might theoretically do to actually dissecting how it fundamentally changes the physical flow of data during a real-world crisis.
Yeah, so let's unpack that, starting right where the mission actually happens, the shop floor.
The artisans.
Yes, right, the mechanic. The Pentagon is hyper-focused on tackling this idea of contested logistics. So if I'm a mechanic at CCAD and I'm dealing with a supply chain that's under physical or maybe cyber threat, how does artificial intelligence physically keep me moving?
Well, to really understand that, you have to look at contested logistics fundamentally as a data problem. The DoD is pushing really hard on the proposed JWCC follow-on.
And JWCC, that's the Joint Warfighting Cloud capability, right?
Exactly, yeah. It's the military's secure pipeline to commercial cloud computing. But the crucial mechanism in this new draft is the really heavy emphasis on edge computing.
Okay, wait, so by edge computing, we mean processing the data locally, right where it's gathered, instead of, sending it thousands of miles away to some massive server farm in Virginia just to get a single answer.
That is the exact mechanism, yeah. I mean, when you're in a contested environment, bandwidth is a luxury you just do not have. Sending data packets back and forth creates a lot of latency, and it creates a massive vulnerability for interception.
Oh, for sure.
If we look at what the military health system's doing right now, they're completely reimagining health IT from the battlefield straight to the exam room using this exact same principle.
Wow, really?
Yeah, and the hard lesson they're learning is that you have to connect the data about people, supplies, and risk before an AI can actually calculate an outcome. So on the depot floor, an AI diagnostic tool cannot calculate a workaround for a missing rotor component if it doesn't already have local secure access to the current parts visibility and, the shop floor safety protocols.
Right, which brings us directly to the hardware side of things. Google just released a new model. It's called Gemma 412B. And the fascinating part to me is that they designed this model to run locally on just an ordinary laptop with 16 gigabytes of RAM.
Yeah, that's huge.
No internet required at all. But, putting a massive neural network on a standard laptop, that has to require some serious technical compromise, right? How are they fitting that much intelligence into such a small memory footprint?
Well, they do it through a mathematical process called quantization.
Quantization.
Okay. Right. And without getting totally bogged down in the math, it basically compresses the weight of the model's parameters. So it requires vastly less computing power to generate an answer.
Oh, I see.
It allows a relatively small machine to hold just an immense amount of technical knowledge completely offline. I mean, the Gemma 4 release is a massive signal for the future of disconnected troubleshooting.
It's basically like downloading a digital master mechanic directly into your toolkit before you deploy.
It really is. But, and I need to draw a very hard line here, we have to distinguish between that future state and our current operational security.
Yeah. Security is always the catch.
Exactly. While these offline open source models definitely represent where we are going, artisans should absolutely not be trying to download these models onto their everyday workstations right now.
Right, because bypassing network security to install some unauthorized AI model is, well, it's a fantastic way to introduce a massive vulnerability right into the depot.
Precisely. That is exactly why the authority to operate, or ATO process, exists. For daily, unclassified work right now, mechanics must lean on authorized DoD tools. Things like GenAI.mil or Ask Sage.
Right, the improved ones.
Yeah, those platforms have been explicitly engineered to survive the whole ATO grind. They operate within an impact level 5 or IL5 environment.
And just for everyone listening, IL5 means the data is completely walled off and secure. Right.
You got it. It provides an approved, safe pathway to query dense technical manuals and maintenance procedures without putting the wider network at risk.
Okay, so the mechanic now has this local approved AI giving them the right procedures even when the network goes down. But that local fix kind of creates a macro problem, doesn't it?
How so?
Well, if 100 mechanics are fixing components offline, how does the command center know what parts were just consumed? That data vacuum seems like exactly what the analysts are struggling to fill across the OIB, the organic industrial base.
Oh, absolutely. The transition from physical action on the floor to actual operational visibility for the analyst is notoriously fragmented.
Yeah.
We are actually seeing DISA, the Defense Information Systems Agency, actively testing secure mission partner environment capabilities out in the Indo-Pacific specifically to solve this issue.
So they're trying to build the plumbing, basically.
Exactly, the plumbing that allows secure data movement across totally different organizations.
You know, I noticed this data movement challenge is colliding directly with the big push for predictive analytics. Like, the National Institute of Standards and Technology, NIST, is expanding its AI consortium right now.
Right, I saw it.
And at the same time, the Department of Health and Human Services, HHS, is pushing states to use predictive analytics in child welfare programs. But how does a child welfare algorithm connect to a depot analyst who's forecasting aviation parts?
It connects through the mathematical mechanism of explainability.
Explainability.
Yeah, think about it. In child welfare, the stakes are literal human lives. If an algorithm flags a home as high risk, a judge cannot just sit there and accept, well, the computer said so.
Right. They need to know why.
It's exactly. Was the decision based on historical data, an income threshold, some bias metric? And the exact same mechanism applies to depot forecasting. If an AI tells an analyst a specific rotor blade is highly likely to fail and recommends grounding a fleet, the commander needs that mathematical audit trail.
Makes total sense.
Analysts have to establish really solid measurement baselines so the AI's output is explainable, trusted, and frankly, legally defensible.
Wait, hold on. I need to push back on this setup a little bit. If I'm an analyst and I'm putting all this highly sensitive OIB readiness data into a generative AI tool to, chew through my spreadsheets and find those baselines, aren't I just feeding the larger commercial AI model?
I see what you're saying.
Like, how does the DoD actually prevent a depot analyst from accidentally leaking our parts vulnerabilities out to the open web?
And this is exactly where understanding the mechanics of that IL5 walled garden becomes critical. When you use an authorized tool, like Microsoft Copilot, within the DoD environment, your data does not become training material for the global foundational model.
Oh, so it's separated.
Totally. The architecture is physically and cryptographically partitioned. So Copilot can automate all the heavy lifting of crunching that Excel data, but the data stays strictly within your tenant.
Okay, good. But once Copilot synthesizes that data, how do they solve the cross-organizational sharing problem across the entire OIB?
That is exactly the role of Army Vantage. It provides the secure, governed platform where you can actually share those synthesized insights across different commands. It ensures the data moves, the analytics run, but crucially, an accountable human remains in the loop to make the final operational decision based on that explainable data.
Okay, so you've got secure data, but you still have to manage the humans doing the actual work.
Always the hardest part.
Yeah. Let's look at the team leads and supervisors who are handling the workflows, the rostering, and just dealing with the friction of daily administration. The big industry buzzword taking over this week is Agentic AI.
Yes, we're shifting from generative to agentic.
Let's define the difference mechanically for everyone. Generative AI answers a question or drafts a document, but agentic AI acts like an independent agent. It actually goes across different software applications and executes actions completely on its own.
And that operational independence is exactly why supervisors need to pay very close attention. Agentic AI requires absolute platform discipline.
Right.
I mean, an AI agent handling shift schedules or submitting status updates needs incredibly rigid, programmed boundaries.
Because without boundaries, it's not a helpful tool. It's basically a rogue employee. It's like slipping a fake work order into a massive stack of legitimate ones.
Yeah, that's a good way to put it.
The supervisor, or the AI agent in this case, is processing the stack so fast it doesn't even realize the form at the bottom says, unlock all the depot doors and wipe the server. That kind of manipulations, that's called a prompt injection attack, right?
That's a brilliant way to visualize it. Yes,
Yeah.
a prompt injection attack is when malicious code is disguised as a standard user request, and it basically tricks the AI into executing a command it really shouldn't. This is such a severe threat right now that OpenAI just unveiled lockdown mode specifically to protect sensitive data from these attacks.
Wow. If the commercial sector is building emergency lockdown modes, the threat is clearly escalating.
Oh, without a doubt. Which is exactly why the Cybersecurity and Infrastructure Security Agency, CISA, is really close to issuing a new cyber AI directive.
Right.
It ties directly into the recent AI executive order that mandates much tighter cybersecurity rules. So for supervisors, the mandate is super clear. You have to coordinate cyber hygiene as AI enters your daily workflows. You cannot let your teams just improvise with unsupported tools on the open web.
Yeah, that's a disaster waiting to happen.
Exactly. If you want to automate rostering or draft status reports, you enforce the use of authorized hardened paths, things like Copilot or GenAI.mil.
Keep the team inside the walled garden where the security protocols are actually active.
That's exactly.
Okay, so let's zoom out from managing the teams to managing the entire enterprise. The executive level, the commanders and directors at AMCOM responsible for high-level strategy and return on investment. We've talked about a lot of different tools today. How do executives buy all these AI capabilities without getting trapped in single vendor lock-in, where they're stuck paying a massive bill for obsolete tech 3 years from now?
Well, they do it by fundamentally changing the architecture of how the Pentagon actually acquires software. They are moving aggressively away from these monolithic single-vendor contracts.
Okay.
Instead, they are utilizing that GWCC marketplace we talked about to build modular cloud-like architectures. Think of it kind of like building with digital Lego bricks.
I like that analogy.
It gives commanders the strategic flexibility to plug and play the best analytical tool today and then easily swap it out for a better one tomorrow without having to tear down the entire infrastructure.
But, I'm looking at the policy side, and I see a massive contradiction here. There's a draft circulating right now for the bipartisan Great American AI Act, and it's proposing a really rigid new federal AI governance framework.
Right, I've seen that.
House lawmakers are even proposing a structure that would preempt state AI laws for 3 years. Doesn't a highly centralized, top-down federal mandate completely contradict the idea of modular, agile, plug-and-play cloud architectures? Like, how can AMCOM be agile if they're waiting on a slow federal bureaucracy to approve every single new vendor?
It seems like a paradox, I know, but mechanically, federal governance is actually what makes modularity possible.
Really? How so?
Well, going back to the Lego bricks to build with them, every single brick has to have the exact same standard connection points, regardless of who manufactured it. Highly centralized policy creates those standard connection points.
Oh, like the APIs and security thresholds.
Exactly. The data formats, the APIs. It means future vendor contracts will have strict interoperability baked in from day one. It forces the commercial vendors to adapt to the DoD's compliance structure rather than the DoD having to adapt to a dozen different proprietary systems.
Okay, that makes perfect sense. The rules create the standardized socket so the tools can actually plug and play.
Precisely.
But while those rules are being written, there is significant friction. Several military leaders are loudly urging caution right now amidst this massive push to get AI onto the battlefield and into the supply chain.
And honestly, their caution is very warranted. The balance between deployment speed and operational risk, that's the executive's daily tightrope. Executives absolutely must demand measurable mission benefit. They have to insist on rigorous testing and human judgment before they go scaling these models into wide-ranging operational decisions.
Yep.
To manage this, leaders should really heavily leverage Army Vantage. Use it to visualize the high-level strategy, track the actual return on investment of these pilot programs, and just ensure every AI capability deployed remains governable and strictly within that approved DoD framework.
Verify the ROI before you trust the tool.
Exactly.
All right, so we've covered the shop floor all the way to the boardroom. Now we are going to make a distinct tonal shift. It is time to look at what is coming next on the industry radar. As a reminder, the tools we are about to discuss are for home lab or industry awareness only. They are commercial tech and are not currently authorized for CUI-controlled unclassified information or depot networks.
Always good to clarify that.
Definitely. So looking at the commercial sector gives us a really good preview of the hurdles heading toward the military. And the first massive challenge flashing on the radar is the fundamental cost of artificial intelligence. The industry is scrambling right now to manage runaway costs associated with computing power, specifically measured in what they call tokens.
Yeah, and this is a crucial mechanical difference in how software works now. Traditionally, you bought a software license for a flat fee and you were done.
Right.
AI just doesn't work like that. It's a metered utility, exactly like electricity or water. Every single time you ask a large language model a question, it breaks your text down into tokens to process it, and that costs a fraction of a cent in server compute power.
Which doesn't sound like much until you have 10,000 employees querying the system 50 times a day.
Exactly. And that token bill is really coming due across the industry. For the Army's future, it's a stark warning. Right now, a lot of AI use across the enterprise is subsidized because it's in the pilot phase.
Ah, I see.
But if commands don't build rigorous cost controls and usage telemetry into their systems today, those subsidized pilots are going to quickly become unfunded production habits. You do not want to find out that a new automated reporting tool just burned through its entire annual compute budget in 3 weeks just because nobody was monitoring the token burn rate.
Wow. Yeah, token economics is going to be a mandatory skill for future project managers, for sure.
Definitely.
Finally, I want to highlight Microsoft's Project Solara. This completely upends how we think about mobile devices. It is an Android operating system designed specifically for AI agents instead of traditional apps. So mechanically, how does an operating system for agents differ from the phone that's in my pocket right now?
Well, right now, your phone's operating system is basically just a launcher. You have to physically open a specific app, navigate its interface, fill out a form, and hit submit.
Right.
Project Solara suggests a near future where the AI agent is the nervous system of the phone. You don't open an app at all. You simply speak a complex command to the authorized agent, and it autonomously navigates all the back-end systems, APIs, and databases to accomplish the task for you.
So it entirely removes the friction of the user interface.
It does. I mean, think about government mobile workflows, maintenance checks, supply requests, incident reports. Shifting from manually filling out digital forms to governed task delegation could radically accelerate operational speed.
That's incredible. Before we go, think about this. As Project Solara and Agentic AI take over the back-end execution of these logistics tasks, the most valuable skill for an Army mechanic or an OIB analyst in 5 years might not be turning a wrench faster or building a better spreadsheet.
No, probably not.
The ultimate skill will be knowing exactly how to write the perfect, precise prompt to command the machine to do it for you.
That's a really powerful thought to leave on.
Well, from local models keeping mechanics informed offline to modular cloud architectures giving commanders strategic flexibility, AI is fundamentally rewiring how the depot operates. Thanks for joining us. Whether you're turning wrenches in the hangars or crunching numbers for the command team, you are the engine that keeps Army aviation ready. Stay safe, stay innovative, and we'll see you on the next Depot AI Brief.